warahmatullahi wabarakatuh. Saya perkenalkan diri saya. Let me introduce myself. I'm AZLINA IDRIS, from Universitas. Okay, so for your information, I'm from School of Electrical Engineering, College of Engineering. Okay, so today my presentation and title is Towards Industry 5.0 with Massive Internet of Things, Technology and System. So before I go details about my lecture, let me show you or explain to you what is the objective of this presentation. Okay, so the first one is I would like to explain the latest technology available in industry related to massive Internet of Things for IR 5.0. And then the second one is differentiate the relationship between IoT and massive Internet of Things. So what is the difference between Internet of Things and what is the difference between massive Internet of Things? So you need to understand IoT first, and then you can differentiate between IoT and massive IoT. Okay, so these topics currently quite popular for the researchers right now. Okay, and then the third one is recognize the need and application of massive Internet of Things system. Okay, so next. Okay, so this is my presentation outline. Okay, first of all, I would like to give some introduction about IR 5.0 technology, evolution of IR 5.0 starting from IR 1.0 until IR 5.0. Okay, and then what is massive Internet of Things? What is the difference between IoT and massive Internet of Things? Okay, and then the third one is massive IoT, the benefits and examples of massive IoT. Then the last one is massive IoT needs and application. Okay, this one I will show you the examples of needs for massive IoT and what is the examples of application currently used for massive IoT. So next. Okay, so right now I will discuss details about the new revolution industry 5.0. So this is the current technology. We are still using IR 4.0, but right now we are starting to go to the IR 5.0 technologies. Okay, next. Okay, this is the Industrial Revolution 5.0. We start with the Industrial Revolution 1.0. So, Industrial 1.0, Revolution 1.0, machine replace the labor works. So, Industrial 1.0, from machine will start to replace the labor work. And then 2.0, steam engines are replaced by electrical machines. So it starts from machine, from mechanization to the electrification. And then the third one, Industrial Revolution 3.0, automation. And then Industrial 4.0, adoption of IoT, AI, cybersecurity. So starting evolution IR 4.0 with the digitalization. So and then the last one is 5.0, human work alongside. So starting Industrial 5.0, more on personalization, humanization. So more on human along work side. So you need to understand between IR 4.0. So IR 4.0 starting from machine to machine. IR 5.0 human to machine. And for the future, IR 6.0 is nature to machine. Have you pernah tengok cerita Avatar? Avatar is Industrial 6.0, nature to machine. Okay, so next. Industrial Revolution 5.0, human-centric. So the first one is more on human-centric. Tadi I mentioned that dia more humanization. So human-centric, so promotes talent. So human-centric promotes talents, diversity and empowerment. Industrial Revolution 5.0 more focusing on the sustainable, leads action on sustainability and respect planetary boundaries. And the last one is resilient. Resilient is agile and resilient with flexible and adaptability technology. So Industrial Revolution 5.0 focusing on human-centric, sustainable and resilient. Okay, and then next. Why Industry Revolution 5.0? So by using the Industry Revolution 5.0, of course, we can reduce the cost due to resource efficiency. So because of the revolution of Industry Revolution 5.0, yang humanization, so we can reduce the cost because we don't need to use so many number of employee. So that means automatically there's sumber manusia dikurangkan, so automatically boleh reduce cost lah. Okay, sebab human to nature, so human can control banyak benda. Okay, and then empowered workers remaining in control, competitive industry by attracting best talent, adapted training for evolving skills, competition age in new markets, and improve safety and well-being. So you can see that over here, by using Industry Revolution 5.0, we can reduce cost, we can empower workers, we can produce the competitive industries by attracting best talent, adapted training for evolving skills, competitive age in new market, and improve safety and well-being. Okay, next. Society 5.0. Have you heard about Society 5.0? You pernah dengar tak Society 5.0? So nowadays Society 5.0 ni adalah introduced from the Japan. So described as a sudden change in the structure and nature of society, such as advance in culture, philosophy, and technology. So Society 5.0 is still use IR 4.0 technologies, but it focusing on the society, impact to the society part. Okay, so understand why we call it Society 5.0, because it still use the technology IR 4.0, but it will impact to the society, focusing on the impact to the society. So the latest Revolution Society 5.0 combines the creativity of people with digital technologies to lead us towards sustainable development. Okay, next. So what is IoT? I think that most of you know about IoT. Have you heard about IoT? Expert in IoT. Okay. So IoT, internet device embedded in various systems to the internet. Once we talk about IoT, must have the internet. So internet. So when device can represent themselves digitally, then can be controlled from anywhere. Once you use IoT, you can control the system anywhere and anytime, as long as it have the internet network. Okay, the connectivity then helps us capture more data from more places, ensuring more ways of increasing efficiency. So by using the IoT, you can get information anywhere and anytime. Okay, in Malaysia, device connected to internet. So once we talk about Internet of Things, of course we need to have IoT sensors. IoT sensor. Kalau if you use Internet of Things, must have the sensor. So in Malaysia, we spend almost 8.3 billion in year 2019, and in year 2022, 13.5 billion. But starting in year 2035, for this year, we spend almost 21.5 billion. Okay, so you can see that the cost expense almost will be increasing yearly. So things in IoT should post 3 C's. So things in IoT have 3 C's. The first one is connect, compute, and communicate. So things itself do the process of compute, connect, and communicate. So for example, design the things, connect, it will use sensor. If you want to do the connection, you need to have a sensor. Compute, you use a microcontroller, and communicate, we are using computer communication interface. For example, handphone. Okay, components of IoT. So for the components of IoT, you need to have sensors, connectivity, and people and process. So you need to understand what is sensors, what is connectivity, and what is people and process. So for sensors, so to collect data, for example, we need to have IoT device. So we need to have, for example, sensor, antenna, and also microcontroller. And then from to collect data, you will pass through the transceiver, which is a transceiver will collect and transfer the data by using the IoT hub or IoT gateway. And lastly, the data will transfer to the user interface, for example, smartphone, human machine, or something like that, to analyze the data. Okay. So you need to understand that different sensors have a different application. So, for example, if you want to identify the position or present proximity, so it have their own sensor. So the sensor, the application of sensor, you can measure the motion, velocity, displacement. You can have a sensor specific to temperature, specific to humidity, moisture, acoustic, and so on. Okay. So connectivity, this input are digitalized and based on the network. You can see that over here we are using, of course, network. So we are using PAN. Okay, so connectivity, we are using personal area network, which is less than 30 feet, more than 30 feet. Sorry, 30 feet. LAN, local area network. We tahu tak berapa distance? Tahu kan? 1 kilometer to 10 kilometer. Network dia. And then MAN, metropolitan area network, normally starting from 5 kilometer to 50 kilometer. And for wide area network, more than maximum is 100,000 kilometer. So among between other countries. Okay. So people and process. So we can, for example, for the customer relationship and support, location and packing, financial and remote monitoring and maintenance. So this one is focusing on people and process. So you can see that over here, the main component of IoT is sensor, connectivity, people and process. Okay, next. So IoT. Enter. So IoT architecture. So over here, device. So you have the sensor, or you have the sensor over here, and then the data over here. You have internet protocol and then it will pass through the gateway, and from gateway it will pass to the IoT cloud platform. Then from the IoT cloud platform, it will go to the application. So the data will pass to the handphone, for example. Okay. So there are various architecture of IoT. So short range, medium range, and long range. So short range, normally we use LoRa, LRWPAN, BLE, Z-Wave, and WiGig. So that one is for short range. But for medium range, normally Wi-Fi, IEEE, ZigBee, and wireless massive. For long range, LoRa, and this one is very popular, LoRa 1. LoRa, narrowband IoT, Sigfox, WY-SAN, in-venue, dash, and wireless. So you need to understand that if you use a massive Internet of Things, we are focusing on the long range. Okay. So this one is IoT connectivity infra short range. So we have IP address. From IP address, will pass through the gateway, and then it will pass through the Wi-Fi network server. So Wi-Fi are focusing only for the short range. Okay, for the medium range, over here, we use IP address, for example, living room, and then the signal, for example, smart home. Smart home, Your smart home. Yeah, so smart home. You can pass data through the gateway and pass through the Wi-Fi. And the last one is for long range. For LoRa 1 system architecture, we use radio ID. We did not use IP address, radio ID, because untuk microwave, the data must be in microwave, and it will pass through the LoRa gateway, and then it will pass through the server, BSS server, and LoRa X server. So you can see that over here, long range, normally we use LoRa 1. So LoRa 1, if you want to use LoRa 1, the best microprocessor is Raspberry Pi. It can go for the maximum 15 km. So IoT connectivity technology versus distance. You can see that from here, the nearest center. You can see that IoT connectivity technology versus distance. Okay, so the shortest distance is Bluetooth and the longer distance is satellite. So you can see that over here, Bluetooth, the first one, the second one is Wi-Fi, and then the third one LTE, the fourth one LoRaWAN, narrowband IoT or LTE CAT machine, and then GSM Sigfox, and the last one is satellite. You can see that from here, this is the IoT connectivity technology versus distance. So you need to understand the distance. You can see that over here, the distance for LoRaWAN is can go for the longer distance compared to Wi-Fi. Okay. So this is the gateway to the future. So for the future cloud and service plus platform, you can see that at the same time you have the data, so many data over here. For example, from smart cities, smart hospitals, smart highways, smart factories. So there are so many data. So how you handle the data over here? So it become a problem. And how can we handle large stream of data from massive IoT nodes? Okay. Is it okay? So IoT you already understand the component of IoT things tadi kan, component dia sensor tadi, connectivity and also people kan. So right now we have a large stream of data. So how we handle it? So we are using massive IoT. So what is massive IoT? Okay, so massive IoT is a volume or number of connections spread over a very large geographical area. So by using the IoT, massive IoT, automatically it can produce a lower bandwidth, can increase the complexity, can reduce the complexity, can reduce the cost, and can reduce the power. You can see that over here there are 4 benefits of using massive IoT. So can produce a lower bandwidth, can reduce complexity, can reduce cost, and also can reduce power. Of course, once we reduce power, automatically we can reduce the cost. So connection technology is categorized as low power wide area network. So the types of connection that are using for massive IoT is low power wide area network, LPWAN. Okay, next. So massive IoT connectivity, there are many types of low power wide area networks. So there are two different types. The first one is licensed spectrum and non-licensed technologies. So for licensed spectrum include narrowband IoT and LTE machine types communication of LTEM. So this one need a license from the government. And then for non-licensed technologies include Sigfox and LoRaWAN. So this one is no need to apply from the government. We just only to buy the license. But for narrowband IoT and LTE machine types communication, we need to apply it from the government. So have wide coverage while consuming low power. So in this case, you can see that by using narrowband IoT, by using massive Internet of Things, it can cover for a wider area. Okay, and then at the same time, it can produce a low power. Okay, so sensors deployed in the field are capable of long service times without having to replace them frequently. So the sensor, the field are capable of long service time without having to replace them frequently. So tidak perlu replace so many times, because the power. Because the sensor deployed in the field are capable of long service times without having to replace them frequently. So next, okay. So this is a narrowband IoT architecture. So it's come from the smart infrastructure, healthcare, security and surveillance, transportation, consumer and home. So there are so many data transmit at the same time. So you use MBB or narrowband IoT in nodes BSS, and it will pass through the MME and also as gateway. So this is the process until it will receive to the IoT cloud application server. You can see that over here, we use narrowband IoT architecture for different applications at the same time. Okay, so Sigfox architecture principles. So over here you are using Sigfox. So the data will pass through the using the RF radio frequency signals. We pass through the session, and then we pass through the satellite, internet, and lastly server packet. This one is example of Sigfox architecture. And how can massive IoT help us? So it's one by using IoT platform, it can reduce cost, and at the same time can improve the process of efficiency, can improve the asset utilization, can improve the productivity. And the growth and convergence in terms of data, process, and also things. So the growth and convergence in terms of data, process, and things. So the benefit of massive IoT, there are 6 benefits of using massive IoT. The first one is low cost sensors that consume very little power. So that means low cost with low power, just only consume very little power. The second one is sensors whose battery life will last 5 years or more. So long lasting, battery is long lasting for sensor. The third one is small form factor that can be embedded practically anywhere. And the fourth one easily connects to low power, low bandwidth network, which have excellent coverage. You can see that over here, we just only use for low power, low bandwidth network, but it can cover wide area coverage. Okay, the fifth one is the ability to scale the network quickly and efficiently. And the last one is embedded with massive IoT platform with full end-to-end application communication security. In terms of security, by using massive IoT is very good. Okay. So this one is example of massive IoT examples. Parking lot monitoring. You can use for water or air quality monitoring. You can use for power usage monitoring. Industrial machine monitoring, soil monitoring, agriculture also can use massive IoT technologies. Livestock tracking, industry, and also logistic and asset tracking. This is the examples of the application if you want to use massive IoT. Okay, so I will explain just a little bit about examples of smart metering. So use remote meter reading for electric or water supplier. So right now, you have electrical meter or water meter. So meters can detect leakage, report theft, and even stop the supply. Then the data will pass through the gateway with fog computing, and it will pass to the LoRa gateway, and it will pass to the cloud services. So at the center, we can monitor monitor the condition of the water meter or electrical meter of the customer. Okay. The next one is smart agriculture. So we can use case here, monitor level of moisture in soil. So if you want to monitor the level of moisture in soil, so you use IoT to monitor level of moisture in soil to help farmers make timely irrigation decisions to indicate when fertilizer or watering are required. So that means the system will send alert to farmers via text messaging when level of moisture below an acceptable threshold. Otherwise, data will be kept in the gateway. So, you can see that over here, farmer can monitoring the crops. Okay, so this is the examples of my student FIP project, final year project to do the massive IoT. So the topics is viable energy for smart water monitoring system using ultrasonic and pH sensor. So it consists of two functions to detect the water quality and to detect the water levels. Okay, so problem statement: establish modeling system for flood and water quality is not very efficient as the system works separately. So the conventional method to acquire information is time consuming as the current system does not immediately notify people. So this is the problem statement. Why my students produce this topic? Because the main problem is, as I mentioned from this slide. Okay. So this is a block diagram of the research, starting from the solar energy and then battery, Raspberry Pi, because my student using LoRa 1, and then it will use two different types of sensor, ultrasonic sensor and pH sensor. So ultrasonic sensor is focusing on the water level. pH sensor is focusing on the water quality. As I mentioned before, which is different sensor have a different application. Okay, and then it will pass through the Raspberry Pi, and then through buzzer, and it will pass through the display, ThinkSpeak, and also authority and community. So next, enter. Okay, enter one more time. Okay. So this is the result from research. We have two different results. The first one is ultrasonic sensor. So used to measure water level placed in a pipe for accurate measurement. So there are you can see that from the ultrasonic sensor, the result shows that there are two different types of sensor over here. Ultrasonic sensor GSN SR040 and also HC SR04. So you can see that from here, the percentage of error for GSN SR040 produces 58% and HC SR04 is 2.17%. So in this case, for water level condition, so for level 1, if the value of range of water level is greater or equals 1.3, so that means the status is safe. But if level 2, 0.8 to 1.29 alert, and level 3 less than 0.8, dangerous. Okay, so next. Enter one more time. Okay. So pH sensor, there are two different types of pH sensor, analog and digital. So the result shows that the analog produces 2.72% and digital produces almost 21.68%. So you can see that from here, analog is better than digital. Okay, next. Yes. Okay, so you can see that the result from ThinkSpeak shows that water level 3.8 and pH level 5.3. So if 5.3, it is in dangerous level. Okay. So as a conclusion, the internet gave us the opportunity to connect in ways we could never have dreamed possible. So the Internet of Things will take us beyond connection to become part of living with global nervous systems. That's all from my lecture for today. Hope that you will understand about the details about massive, what is the difference between massive IoT and IoT. Okay, so.
Okay.